direction. So that one I called F1, and this one I called F2. F F1, these are in the same direction, so they were just some of these ones, right? Let's say A, B, C, and D. So A F1 was FB plus FD, and this one was F was FA plus F, right?
Assalamu alaikum,
Is
sir.
that yes? Walaikum salam, walaikum salam. We are just discussing the previous part in which so this is what we did in this question, right, Arsana?
Yes, sir.
Then we calculated what was F1, we calculated what was F2, and then we found out the resultant. Resultant was because this was at 90 degree, so this was F1 square, F2 square plus 2F1, F2 cos of 90. So this cos 90 was 0, so we got this. That was the whole idea. What was the doubt in this question? What was the doubt?
No, sir, I didn't have any doubt. I just wanted to refresh my memory because I kind of forgot about the concept.
Oh, yes, yes. Oh,
Yes, sir, I understand it. Yes, I
yeah, this
understand
is
now.
what we did. Now let us go to the next topic. So equilibrium we have done. Equilibrium was of two types. One was when one point was at equilibrium, and the other was when the whole system was at equilibrium, right? So that was the equilibrium. Any doubt from the equilibrium portion?
No, sir.
Okay, so then we can start the next topic, and that is equilibrium. I should this one, right? What is right? So that is called
Hello, sir. Sir, just stop.
Okay. Yes. Wi-Fi is giving me some
Yes, sir.
headache. Yeah, my Wi-Fi is giving me. I
It's
have
fine, sir.
talked the Wi-Fi provider, but I have not got the perfect or the full resolution. Okay. So space around the charge particle in which we can experience the Coulomb force, right? Right. So let's say, and it is also defined as, it is also defined as the force per unit charge, right? So it is defined like that. So let's say, and it is a vector quantity. Right. So if it is a vector quantity, again the superposition principle will be applied, right? So we will talk about that later. And its SI unit is volt per meter or Newton, and also we can write as Newton per coulomb. So both are the SI, right? We can represent it as Newton per coulomb or volt per. So both we can. Usually we write it in Newton per coulomb. Right. This is it, and mathematically how do we represent? So E vector. This is F by Q. Okay. So let's say that we have what is the Coulomb force, right? We have this Coulomb force. This is Q1, Q2, and this is the separation, right? So if I want to calculate the electric field at this point, right? If I want to calculate the electric field at this point, then I'll have to forget about this charge. So electric field at, let's say, electric field at A would be due to which charge? Electric field at A would be due to which charge? Yes.
So I didn't understand the question.
Yeah. So let's
Due to the
say,
Q1 charge?
yeah. So electric field at A point would be not due to this charge. We will just omit this out. So electric field at A point would be due to this charge. Okay. So
So the
electric field,
space around the particle.
yeah. So space around Q2 in which we can
Okay.
experience this coulombs, right? So that is called electric. So electric field at EA, that would be F by Q1. So this would be KQ2 by R square. Okay, is that clear?
Yes, sir.
So then we can define the electric field as, let's say, we have this charge, right? This is Q, and we are calculating the electric field at this point, right? This is the P point at which we are calculating the electric field. So area around in every region we can feel the electric field, right? But let's say we want to calculate the electric field at this point, so that would be simply, let's say E, and that would be KQ by R square. So that is the magnetic of electron. Is that clear?
Yes, sir.
So that is the electric field due to a point. Right. So whenever we are given, let's say, whenever we are giving some charge, and we want to calculate the electric field at this point, P point. So we just calculate the separation, the distance between this charge and this point, and then if we want to calculate, so we just write it as KQ by R square, right? So that is the electric. And you guys please note it down, and then we will try to understand about the other properties of electron. Yes, whenever you guys want me to scroll down, please.
So scroll down.
So from let's say electric field, if I want to calculate the Coulomb force, so I just multiply this charge with this electric field, right? So if I multiply, let's say Q 1 to EA, right? Then I will get the force, Coulomb force. So this that would be what KQ1 Q2 by R. So whenever we want to calculate the electric field at a particular point, we just talk about the other charges. We forget about that charge, right? So, or we can also say that we calculate the electric force, Coulomb force between these two charges, and divide it by the charge on which we are calculating the electric field. So that we can
Sir, can you scroll up?
roll up or down.
Up,
Down.
up.
Up. Oh, which part?
Sir, I'll be going to the washroom. I'll come back in 3 minutes.
Yeah. Whenever you return, just and me, whenever you have noted it down, please tell me so that I can scroll down. Yes, Mira, noted.
Yes,
See
sir.
that
It's,
you note it down. Then, then this part. Yeah, so just note down this part. That if we have a point, right? If we have a discharge Q and we want to calculate the electric field at this point, so that would be simply this.
sir, just scroll up. I have to see the diagram.
Which diagram? This one.
More up, sir. Yeah.
This
Yeah. Yes, sir. You can scroll down. So, sir, ray optics finished, right?
done. No, no,
Okay.
no. The
So,
optics we are just doing. Yes,
this is
yes.
the
We.
first law of electric field.
What are you saying? Yeah.
Is ray
So in the
optics done?
previous
Yeah.
class, we did this equilibrium question, right? No, no, no. So this is another class, right? In this class, we are doing the first and two. We are doing the first book, and in that class, we are doing the second ray optics, right?
Sir,
Yeah.
I
These are
can't
two
hear you
separate
properly.
classes, and yeah. Am I audible now? Am I audible now, please? Am I
Yes, sir.
audible now?
Your voice is lagging
Yeah, I guess there
in
are some
between.
internet issues. Yeah. So am I
Mm.
audible clear now?
Yes, sir. No. Okay.
Yeah. So I am saying that we are doing two classes simultaneously. In one class with you and Arsalan, we are doing the first, right? And in some other class, we are doing the second, right? So in that
Oh,
in that class, I am doing ray optics, and in this class, we have just started from the beginning, right? So these are two
this is
separate
standard
classes, so that
electric field.
yeah. So this is from the first chapter, electric charges and fields, and yeah. So in that way, we can
Oh,
cover those syllabus, right? Simultaneously.
okay, okay, sir. Sure.
Yeah, so ray optics, in the previous class we couldn't do because my internet was not working properly. So in the next class, I will talk about prism and optical measurements. These two topics are remaining in the ray optics, and then we'll start wave optics. Those will not take time. Only these things are very important. First book is the most important. Very Zartan. Arsalan, did you come back? Hello, Arsalan, are you there? It's 3 minutes over. These 3 minutes are not over, right? So let's wait for Arsalan for 2 minutes. Then we will continue. Okay, Amit.
Yes, sir.
Yeah, and do you have any questions from this electric charges? So up until now, we have done Coulomb force, equilibrium, and electric field we have done. And properties of the charges we have done. So these chapters are very important, right? First four or first six chapters are very crucial. Okay, Absalam.
Yes, sir, I'm back. Yes, sir, I'm back.
You are back. You are back. You are back. You are terminated. Right. You are back. In the voice of Arnold Schwarzenegger. Right. You are back. Okay. So, yeah. So let us talk about. So as we understood about the Coulomb force due to multiple charges, so that we are following the superposition principle. So in a similar manner, in a quite a similar manner, these electric fields also follows superposition principle. And this is of electric field, right? So what is the superposition of electric field says or states? Why this is what I have. Not able to. Yeah, so let's say I have multiple charges, right? And what do I know? Preliminary information. What is the preliminary information? That if I have this P point and I have this Q charge sitting at there. This is the Q charge sitting at there and I am calculating the electric field at this point. So I just calculate the separation and this is the electric field due to point charge, right? So in a similar manner, remembering this thing, let's say I have multiple charges, right? And I'm calculating the electric field at this point. So let's say this is Q1, Q2, Q3, Q4, Q5, Q6. And this is the point electric field. So due to this one, there would be electric field in this direction because due to positive one, this is the electric field, right? So for positive one, that would be this one, right? And yeah, so in this way, I have this electric field due to this one, this electric field, this one, this R2, R3, R4, R5, R6. So electric field at P point, that would be E1 plus E2 plus E3 plus E4 plus E5 plus E6. Remember, all these are vectors, right? So if I write it in a simple manner, so this would be KQ1 by R1 square and R1 had K2 and R2 square, R2 had direction KQ3, R3 square, R3 had direction and so on. So this would be the superposition principle of electric. So electric field, can I erase this? Not, that we have to do. So what does this superposition principle of electric field say? Why it is not, So superposition principle add to multiple charges would be the vector sum of all the individual electric fields due to single charges. Right. So, so as I have written, E would be simply E1 plus E2 plus so on. Yeah. So that is what the superposition principle says. So if I calculate all the individual electric fields, so vector sum of those electric fields, just like the forces, Coulomb forces. So this is what about the superposition principle. Okay, and and let's say again, let us do a simple question on the basis of that. So this would be more clear. Let's say I have again these charges, right? So this is minus q. This is plus 2q, and this is q, and this is minus 2q. So if I calculate the electric field at the center of this square. So again, this is A, and at this point, I'm calculating the electric field, right? So let's say this is O point. I'm calculating the electric field at O. So again, you guys already know that would be electric field. How many contribution would be there at this point? How many contributions would be there?
Sir, 8.
8.
So 6.
So 6. How many charges are there? How many?
Oh no, sir, I meant 4, 4, 4. I saw the.
So 4 contributions would be there, right? So A, B, C, and D. So electric field would be due to EA plus EB plus EC plus and remember, what about the direction of the electric field? So always remember that direction of electric field. So let me write it in here. That direction, and when we'll do the electric field lines, so that would be also clear. So direction of electric field is in the same direction as Coulomb force, right? So this is one way to identify the direction of the electric field. But when we will understand the electric field lines, then we'll be able to easily understand what would be the direction of the electric field. This is one way to understand. And the other way, yeah, we could talk about that. When we will talk about electric field lines, so then we will talk about that. Okay, so we are calculating the electric field at this point, and there would be 4 contributions. So for minus q, the electric field would be in this direction or in this direction. What would be the direction? towards A or away from? Yes. At this point, due to A, what would be the direction? Towards A or away from?
Sir, is it positive or negative? The
Chandan
middle
and
one?
me, what would be the direction of electric field? This is attractive, right? Let's suppose that they are to act, right?
Yes, sir. Sir, can you hear me?
Internet.
Yes, sir.
Yeah, so what I was asking that due to this A point, the electric field would be in which direction? Towards A or away from A? Let's suppose that you have a plus Q charge. So
Sir, towards
towards A. So this would be the electric field due to A, right?
yes, sir.
And due to this C charge, what would be the direction? Away or towards C?
Away from C, sir.
Away from C, right? So this would be in here, right? So, so in this way, you can also see that we can simply add EA and EC, right? Now, what about this B charge? So due to B charge, electric field would be towards B or away from B. What would be the direction?
Sir, away from B.
Away from B, so in this direction, right? And due to D, towards D or away from D?
Towards D, sir.
Towards D, right? So we have this. Good. So now we have all these directions, right? Again, this is at right angle, and we have to figure out the magnitudes of EA, EC, EB, and ED. Magnitudes of EA and EC we can directly add, right? So let us find out what would be the magnitudes of EA. So EA would be how much? That would be K, and this Q divided by the separation. So what is this distance? This distance we have already calculated. If we remember the force calculation, so we already know that what is this distance. This distance was root 2a, right? Because this was a, so hypotenuse is root 2a. And this distance was root 2a by 2. All these distances were same, right? Is that clear, guys?
Yes, sir.
So this was root 2a by 2 whole square. Similarly, let's say C. So this is K, Q divided by root 2 by 2a square. So let us simplify this. This is KQ by 2a square divided by. So this is 2kq by a square. Similarly, this is same 2kq by a square. What is the magnitude of EB? You guys calculate and tell. Both of you guys calculate and tell me what is magnitude of EB. Because we have done the Coulomb force, so we know. Electric field due to B at O.
Sir, EB is equal to
Yes.
K2Q
Yeah.
by root 2 by 2.
Square. Right. So that is the
Yes,
distance.
sir.
Distance square. Whatever R square. So R is root A by 2. Good. Yeah, that is correct. Absolutely. So this is this, and this is 2A square by. So this part cancel, and this is 4KQ by 2 square. And we know that this EB has equal magnitude, so this would be ED would be of same magnitude, right? So ED again would be 4KQ by K square. Correct? Is that clear, everyone? Right?
Yes, sir.
So now let us write this as E net. E net we have to find out magnitude of E net. And we know that these are the vector. Let's say that this is E1, and let's say this is right, draw it perpendicularly, right? So this is 90. So E1 is what? EA plus EC, right? So 2KQ square plus 2KQ square. So 4KQ by K square. Similarly, E2 is how much? 4KQ square. So EB plus EQ, right? Then this would be 8KQ by K square. So now we have E1 and E2. What would be the E net? We already know the properties of the parallelogram law. So if we draw the parallel line here, if we draw the parallel line here, this would be E net, right? So E net magnitude is how much? E1 square plus E2 square plus 2 E1 E2 cos of angle between E1 and E2, that is 90. So again, this is cancelled, and this is 4KQ by A square whole square plus 8KQ by A square. This would be 16K square Q square by A4 plus 64K square Q square by A. Again, we take 16K square Q square by A4 common. So 1 plus 4, right? So this we can take out of the root. So 4KQ by A square and root 5. So that is the electric field at O point. That is the magnitude, and direction you guys already. Direction is towards left. That you guys already. Any doubt in this question? Do you guys have any doubts?
No, sir.
Okay, so then please note down this part, right? And then we will understand about then I will talk about the other. Yeah, whenever you guys want me to uh, scroll down the screen, you guys please. Yes. Yes, whenever you guys want me to scroll down, please. Yes, sir. Noted.
Yes, sir. Scroll down.
Uh, yes. Whenever you guys have noted it down, yes. Whenever you guys want me to scroll down, please. Okay.
Yes, sir. Almost done. I just need to write the
Oh,
E. E. Just scroll down.
Yeah.
So I'm done.
Then, okay. Is this part also noted?
No, sir.
Yes. Whenever you guys have noted it down, please check.
Yes, I'm done.
So the next thing which is important is, so these electric field have a peculiar properties. So these have symmetric property. of electric right. So electric field at the geometrical center of equal or symmetrical distribution of charges is 0, right? And that is called neutral point. So neutral point is that point where electric field is 0, right? So neutral point is place is, or let's see, neutral point is a point in a space where electric field is right. So that is called the neutral point. And what is the symmetric property? So let's say if we have two equal charges, right? Let's say this is plus Q, this is plus Q. So if I calculate the electric field at the center, this is a line and this is the geometrical center. So how much would be that? How much would be the electric field in here? Yes, this is symmetrical distribution, right? So Q charge,
Yes,
Q
sir.
star charge, this is a line, so this is a geometrical center. And electric field at the geometrical center of symmetrical distribution of charges is 0. So in here, electric field is 0. Clear?
Yes, sir.
If it would have been, let's say, 3Q and Q. So now this is not symmetrical, right? This is different. This is different. This one is symmetrical. Equal charges on both the sides. This is not symmetrical, right? So E would not be 0 at the center. Is that clear?
Yes, sir.
Similarly, let's say I have the equilateral triangle. So the charges are at the equilateral, at the vertices of the equilateral triangle. And same charges are there, right? And if I want to find out the electric field at the centroid, how much would be the electric field?
For
Can you tell?
0?
Right? Because these are symmetric. If this would have been 2Q, if this would have been 5Q, and if this would have been asymmetric, then this would not have been 0. Similarly, if you have a square, right? If you have a square, this is symmetric. So without doing the actual calculation, you can tell me that what would be the electric field at this point. What would be the electric field? Now you will have to do all these four contributions, but you already know that these are symmetric. So electric field would be 0. So this is a neutral point, this is a neutral point, this is a neutral, this is not a neutral point, this is a neutral. Is that clear?
Yes, sir.
Okay, similarly, you can have this pentagon also, regular pentagon also, regular pentagon. And if you calculate at this center, so that would also be right. So Q, 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 Q. So electric field at the center. So this is the symmetric properties of the electric. Now let us talk about the most important topic of this chapter, and that is electric type. Right. So what is an electric type? Right. So electric dipole, it consists charges of equal magnitude but opposite polarity and separated by a small distance. Let's say 2 inch. So yeah. So we have these two charges, right? These two charges, they have plus Q, and this is also Q, but this has an opposite polarity. This is minus Q, and they are separated by some distance. And let's say this for easy calculation, let us suppose that this is 2A, right? So this two charges system will be called a dipole, electric dipole. Is this clear? Is this clear, guys?
Yes, sir.
Yeah. So, and then you have these dipoles. So it defines the strength of the dipole, and it is equal to product of charge and the separation. This is the dipole moment. It defines the strength of the dipole, and it is a vector quantity, and its direction is from negative charge, positive charge. Okay. So let's say if we have a dipole minus Q and plus Q, right? And let's say this is the center of the dipole. So the direction of the dipole moment would be in this direction. So that is how we represent this dipole. This is a vector quantity, and its magnitude is the product of charge into separation. So what was the separation we have taken? A. So this is the magnitude of the dipole. Magnitude of dipole. Okay. and it is a vector quantity, so it will have this P and P hat. So magnitude we know that is 2aq. P hat direction would be in this direction, going from negative to positive. This is P hat direction. Is this part clear?
Yes, sir.
Okay, so now the important topic comes, and that is this is very important one. So electric field of a type or an electric type. Right. So for our purposes, we will calculate the electric field at two regions. One is the axial region, and the other one is the equatorial region. So in these 2 points, we will calculate the electric, right? So let's say we have a dipole minus q and plus q. So what is the axial region? So we have this line which is connecting these types, right? So if we are calculating the electric field at this region, okay, if we are calculating the electric field at this region, so this is called the axial. This line is called the axial, right? And inside we cannot calculate the electric field because this is the whole system, right? So we can calculate the electric field at this point, electric field at this point. So this region is called the axial region, and this is the center. And if we calculate at this region, right? So this is called the equatorial region. Perpendicular to this type, right? This is the axial region and this is the equatorial. So we will calculate the electric field of the dipole in here and in here. Is that clear, guys?
Yes, sir.
Okay, so what we will do is that, yeah. So what we will do is that let us try to find out the electric field at the axial point. Okay. So case first is the axial point. So let's say that we have the dipole, and this is the axial point. And we are calculating the electric field at, let's say, this point. At this point, we are calculating, and let's say from center, right? From center, this is the center point. So from center, this is r distance. Okay. And how much is the total distance that we have taken? What was the total separation? How much was that? You guys remember? What was the separation that we took? To A, right? To A separation.
Yes.
This was a 2A. Did I write? Yeah. So, yeah. So in the center, how much would be this distance?
So 2A.
2A is whole distance. This is
Oh, A then.
A and A. Right.
Yes,
Clear,
sir.
guys? So we are calculating the electric field at this P point. So let's say this is A and this is B. So now you guys tell me at this P point, how many contributions from electric field would be there? How many contribution of charges would be there? Yes. How many contributions would be there at P point? If we are calculating the electric field at P point, how many contributions? How many charges are there?
Sir, 2.
Two, sir.
Right, so two. So two contributions would be there. At P point, there would be two contributions, right? One would be due to this charge, other one would be due to this charge. Clear, guys?
Yes, sir.
Yes, sir.
So let us try to find out the electric. So due to this charge, the electric field would be away or towards this charge at P point, towards or away due to this P charge.
Sir,
Towards.
towards.
Attractive. Yeah, due to B, this is positive, and let's assume that in here we have positive charge. So towards or away? You guys are saying towards. Is that an attractive one? Will we get an attractive force if we have plus Q charge in there? We always take the test charge as positive charge. So will we get an attractive force or repulsive force due to plus Q charge?
Sir,
Repulsive
repulsive.
one. So that would be away, right? Right, guys? Is that correct?
Yes, sir.
And due to this minus Q charge, at this point it would be towards or away. Yes, due to minus Q charge. Towards
Sir,
or
towards.
towards, right? So this would be E. Okay. So again, you guys see that these vectors are in the same direction or in opposite direction. These two vectors, same or opposite.
Opposite direction.
So if the vectors are opposite direction, then the E net would be sum or subtraction.
Subtraction.
Subtraction. So this would be E net, right? They are in the same line. There is no angle between them. So this would be EB minus. Is this clear, guys?
Yes, sir.
Okay, so now we have to figure out what is the magnitude of EB and what is the magnitude of EA. We know that the electric field due to point charge is KQ divided by the separation square or the point at which we are calculating. So let me write it as X. So we are calculating the electric field at P point due to B. So that would be how much? KQ divided by BP square. Right, guys?
Yes, sir.
So how much is BP? Can you guys tell me? What is BP? What is BP, guys? I have written all the distances. So you guys tell me what is BP? Let's say this center is O. So what is BP? Arsalan and me, you guys tell. What is BP? Just see this diagram and tell me how much is BP.
Sir, BP is equal to R minus A.
R minus A. So Arsalan is saying R minus A. What about you, mate? What about you? What are you thinking? What is your thought?
Sir, what's the question again?
Question is that how much is this BP distance? Because to calculate EB, that would be charge divided by separation square. So what is BP? Arsalan has said that it is R minus A. What are your thoughts? Or what do you think? Is that correct, or do you have any other answer?
P minus B, sir?
P minus B. Okay, P is a point, right? P is a point.
Okay.
P is a point. You want to calculate the distance. So think about this. R is this distance, total distance. R is this distance. From here to here, it is A. And from here to here, we want to calculate, right? So as Mir has said, if we subtract total R minus this one, then we'll get BP. So BP is R minus A. Is that clear to me?
Yes, sir.
Yes,
This
sir.
is, yeah, KQR minus A whole square. Now you guys tell me what is AP. Both of you guys tell me now what is AP. That is square.
R minus 2A?
R minus. Are we going, are we subtracting or are we adding?
Okay. So,
R plus A.
R plus A. So Arslan is saying R plus A. What about you? Are we
R
going
plus 2A?
to A? So this much is R
Okay. Okay. So, R plus A,
and
yeah.
R plus, right? So R plus. So this is KQ divided by R plus A square. Good. So now we have calculated EB and we have calculated EA. So we can calculate the net force. That is EB minus right. So let us find out that this is EB, which is KQ by R minus A whole square minus of KQ R plus A whole square. Right. So what is common? KQ we can take common, and this is 1 by R minus A whole square divided by KQ and KQ common. 1 by R plus A whole square. So LCM would be how much? LCM would be R square minus A square multiplied by, right? So LCM would be R minus A, R plus A whole square. That would be the LCM. So that is R square minus A square. Is that clear, guys? LCM clear? Is this
Yes,
clear?
sir.
Yeah, you can also think it in this way. We have R minus A, R minus A, R plus A, R plus. So if we take the LCM, that would be R minus A, right? So this would be R minus A and R plus A and R plus A. And then if we take, yeah, and if we take R minus A again, so this is 1 R plus A, R plus A, then we take R plus A, so this is 1 and R plus A and R plus A, this is 1. So this is Then we'll get R minus A, R minus A, R plus A, R plus A. So R minus A, R plus A is R square minus A square. R minus A, R plus A, we have R square minus R square minus A square whole square. That would be it, right? Okay, so this is the LCM. If we divide this by this, so we will get R plus A whole square. So this would be in here minus of R minus A. So if we solve this one, okay, R square minus A square square. This is R square plus A square plus 2RA minus of R square minus 2RA plus A square. So this is KQ R square minus A square whole square R square plus A square plus 2AR minus R square plus 2AR minus A square. So this one cancel, this one cancel. And we have KQ 4AR divide. And we already know that this A is very small. This separation for a dipole and this separation is very small. So separation is very small, right? For a dipole, this 2A is small. So in here we have this R, which is very greater. This R is very greater than A, right? So let's say if we have 1000 and we have 1. So if I square 1000 and if I subtract it with 1 square, so that would be 1000 square only. Is that clear, guys? Is this part clear?
Yes, sir.
Because this would be 10 to the power 6 is how much? Million, right? So 1 million, and if you subtract 1 million with 1, so that is negligible, right? So this we can neglect. So in here also, we can neglect from denominator, we can neglect this A square. So this is R square whole square. So this would be KQ 4AR by R. So this part is cancelled and we have 4AQ K divided by R. And can you guys tell me what is the dipole moment that we have calculated? What was the dipole moment that we have calculated? Right.
2AQ.
So I can write dipole moment is 2AQ. So I can write 2AQ from here. Right. So this would be 2 and 2AQ K divided by R. So this is P, right? So I can write this as 2KP divided by R. So that is the electric field at the axial point. This is the magnitude. Is this part clear, guys? Is this part clear? Yes, hello guys, can you hear me?
Yes, sir.
Yeah, so is this clear? This
Yes, sir.
derivation is when, yeah, this derivation is important. And the direction of the electric field will be in which direction? So you guys clearly can see that this one is of greater value. So direction of electric field is in the same direction as this one. So this is the direction of the electric, right? And which is in the same direction as the dipole moment. So dipole moment is this direction, right? So this is in the direction of the dipole moment. So if I write it in vector form, right? So E direction, E hat direction is in the direction of P hat, right? E net is in the direction of dipole moment, right? So then E axial vector would be how much? This would be 2 kb magnitude and the direction. And direction we know that that is same as the dipole moment. So P and P hat. What would be P and P hat, guys? What is P into P hat? Magnitude into direction. What is that?
So vector.
Vector, right? So this would be 2 kp vector divided by r. So this is the electric field at axial point. Okay, you guys, please note it down. And if you guys have any question, please ask. Symmetric properties we started. Please note it down. And if you guys have any question, please ask. So in the next class, we will calculate the electric field at the equatorial point. So next class, yeah. Do I need to scroll it down?
Just 1 minute more.
After dipole, we
Uh,
will understand. Yeah,
So
yeah, please, please note it down.
oh, sir, I just have to note something down. Up, just go a bit up and be done.
Yeah, this one. This is
Yes, sir.
okay.
Yeah, yeah. So scroll down.
Sir, can you scroll a bit up?
Up.
Yeah, sir.
Yeah.
Just a second. Yeah, sir, you can scroll down.
Let's just scroll down. Just scroll down.
Portion.
Yes, just scroll down.
These portion.
Scroll down.
Hold down.
Yes. Scroll down.
Yeah, whenever you guys have noted it down.
Yes, sir. Done.
Well, Veer, what about you?
Yes, sir, done.
Okay, so yeah, let's stop it.